And this division was established in the year 1962. And presently, so we are doing the work in the following areas, the main areas, you can say, Allison design of bridges, application of advanced composite materials for bridge construction, rehabilitation, research, diagnosis, and rehabilitation of bridges. Dr. Paul is here. Let us welcome Dr. Paul first. Mr. Shivam, kindly hold. Welcome Dr. Paul. So we are doing work in the following areas: research, diagnosis, and rehabilitation of bridges, maintenance management system, such as health monitoring of bridge instrumentation, safety audit of bridges, health assessment and rating of bridges, loading capacity of bridges, and our scientists are working as a member of various committees of IRC and BIS for formulation of codes and guidelines, and use of waste materials such as fly ash, sandy waste, etc. in concrete, applications of visual sensors for health assessment, development of drone for inspection and NDT of bridges, use of jute fibers in development of cyclical components without any concrete, lightweight of FRP big members without any concrete, rotation of various loads, coordinate studies we are doing, fatigue studies on big components, wind tunnel studies, level of calculation, verbal studies, and so on. बहुत से एरिया में काम कर रहे हैं हम लोग. And हमारे पास जो इक्विपमेंट है वो लेटेस्ट और सेट ऑफ इक्विपमेंट है such as latest bridge analysis software design tools, software design softwares. It's like a testing laboratory, dynamic heavy testing laboratory for fatigue testing system, wind tunnel facility. और मुझे आगे पता चला कि जो विंड टनल जो हमारी गजन फैसिलिटी है fatigue testing system that was designed by Dr. Mathur himself. He is present in this hall. Wind tunnel facility है हमारे पास. MBIU we had ordered and new MBIU we also procured. Building instrumentation laboratory, UTM of 300 tons capacity, tube testing machine of 500 tons capacity, biaxial testing machine for elastomeric bearings for 400 ton vertical load and 100 ton horizontal loads, NDT for concrete and steel, and test review of different joints will be optional very soon. During last 64 years of existence of this division, various stalwarts guided the R&D in the field of bridge engineering. This was division was in 1962. At the time, Engineer T.K. Natarajan was the head of division. After that, Dr. P Raychaudhuri took over from him, and he was head of that division for almost 21 years, more than 21 years. Was head of the division, and from them, Dr. M.V.B. Rao and Dr. Ram Kumar is here. Dr. Lakshmi joined online. Dr. Rajiv Garg is here. Mr. Gherwal is here. Mr. Saw is not here. Myself, I am here. Jay Goli also not here. Really, I am second time. So Dr. P Raychaudhuri passed away on August 24, 2016. Then his wife, Dr. P Raychaudhuri, approached CRI to establish a request to establish a annual lecture series, which are accepted by the CRI, and with her support, this lecture series being started in 2018. First lecture series was organized in the institute on August 29, 2018, in which Professor Mahesh Tandon, MD TCPL, is a talk on modern trends in bridge engineering. Subsequently, in 2019, Professor Tarun Khan, emeritus professor and INSAP senior scientist, IIT Bombay, delivered a talk on 6 decades of research in mechanics of composites. In 2020, Shri V.N. Hegde, CEO Scoop Consultant, Mumbai, delivered talk online because there was a corona period. Lesson learned from bridge failures. In 2021, Professor Sujit Kumar Bari, Director Bridge Pilani, delivered a talk in hybrid mode in this hall itself on potential of big data analytics in structural health monitoring. And after that, Dr. N.C. Paul, who is also present here, he delivered the talk in hybrid mode in bridge maintenance management system, lesson learned and way forward. And 2023, Dr. Engineer KP Abraham, Chief Engineer retired CWD delivered talk on innovative construction techniques in construction of Signature Beach, New Delhi. In 2024, Engineer Ashok Basa, FIE Executive and Vice President, World Federation of Engineers Organization, delivered talk on evaluation of bridges. And last year, Professor Prem Krishna, Emeritus Professor IIT Roorkee, delivered talk on development of bridge engineering growth and challenges. And this year, Engineer Vijay Gupta is giving a talk.
Could be eligible for the UK scrappage scheme.
With this background, I will now introduce our
on installation and even more on
great HOD, Dr. Raychaudhuri.
Made lurid and false claims.
He was born in Dogra, which he
played
present
on
in
their fears,
Bangladesh
fueled
on June 20, 1932.
significantly
He completed his schooling in
paranoia
Calcutta
and
and obtained
isolation.
his BSc
I
on
remember from
physics
this one.
in 1951. He did BTech Civil in 1955 and MTech in Structural Engineering in 1956 from IIT Kharagpur. Then he joined CRI in 1957 as Senior Scientific Officer. After joining CRI, he received a fellowship, Council Fellowship, and completed his PhD from University of Leeds, UK in 1964. And after returning from UK Leeds, he joined Bridge Division Lecturer as his head of the division and continued up to his when he took the VRS. Dr. Raychaudhuri was the first full-fledged head of Bridge Division who developed the state-of-the-art infrastructure in the division with his dedication and innovation with the assistance of optimal staff, and made it a center of excellence in the area of condition survey, testing, and rehabilitation of bridges. His other areas of research includes bearing, expansion joints, well foundation, retaining walls, and this is very long. He was given the additional charge of CRA workshop and MBSQ also as a coordinator of a payment also from 1986 to 1988. He rose to position of scientist before taking VRS in 1998. Out of his 31 years of long service in CRI, he served Bridge Division as for 21 years as his head. After taking VRS from the institute, he was associated with several reputed firms as a structural consultant, advisor on various projects of national interest. Released device on 24th August 2016 at the age of 84 years. I will list from his contribution to CRI. The construction of test bed for a strong test floor Bridge Division, which we still be using. Commissioning of bicycle load testing machine for bridge bearings. We are still using that machine, madam. Development of development and utilization of suspension wire method for the diffraction method. This method is being used all over India nowadays for load testing of bridges. Development and utilization of underside pulling technique for load testing of bridges. Development and utilization of long length gauge for train measurements. Large mobile test bed for PED division for design. Commissioning of UTM for the PED division. We're also involved in that. Besides this, he has also handled several externally funded projects in the institute, such as condition survey of Vivekananda Setu, Kolkata, Old IIT Bridge, New Delhi, first Thane Bridge, Mumbai, Ramajan Bridge, Bihar. So that condition survey load testing of Turkish Bridge near Roha Tunnel in Jammu, Subdurgan Flyover, New Delhi, Howrah Bridge, Kolkata, Tezpur over Brahmaputra River in Assam. He has also done the sector consultancy for proof checking and exhibition of Indira Gandhi Indoor Stadium, New Delhi, condition survey of expansion joints of Multan Flyover, New Delhi, and Jolly Bridge, Goa. Besides this, he also associated with several technical committees of IRC and contributed towards the question of number of codes and guidelines. This is so long, but due to proximity time, I'm skipping this. अब ये कहना चाहूँगा कि संस्थान के विकास में बहुत योगदान दिया है और उसके अब डिवीजन को बहुत न्यू हाइट पर ले गए हैं. Thank you. जय हिंद, जय भारत.
Thank you, sir. It is now my privilege to invite Director of CSIR Central Road Research Institute, Dr. C.H. Ravi Shekhar, to kindly address the gathering.
Morning all. Respected Dr. S. Langobaji sir, then Director CRRI, Dr. M. Bhaskar Rao garu, then Head of the Bridge Engineering Division, Dr. Ram Kumar, then Head Bridge Engineering Division, Dr. N.C. Pal, then Engineering Chief, Odisha PWD Department, and all CRRI staff and also the retired staff, all students, scholars, scientists, and technical officers and admin people. Welcome to this lecture series. Also, I respected the chief guest today, Devjani Raychaudhuri, architecture, daughter of late Dr. P Raychaudhuri. Distinguished speaker Sri Vinay Gupta, maybe probably will join another 5-10 minutes. Managing Director, TCPL, colleagues, scientists, researchers, and friends, a very warm welcome to the 9th series of Dr. P Raychaudhuri Memorial Lecture. So it is a privilege to be part of this memorial lecture series, which keeps alive the memory and the professional contribution of Dr. P Raychaudhuri and inspires us to continue tradition of excellence in bridge engineering and infrastructure. So bridge is one of the toughest part in the civil engineering department. It is a connection of the people, not only connection of people, connection of lives of the various people. And it is also the connection of the communities and economies, and their safety, durability, and performance have direct impact on the development of our country. So CSI CRRI has done a lot of work on bridge health monitoring from last so many decades. So particularly we have done 6,000 bridge health monitoring in India, pan-India, throughout India. So a lot of work done by bridge engineering department. 6,000 bridges is not a simple one. It's not easy. Like one bridge, it will take more than 2-3 days to like health monitoring and also like remedial methods. Not only that, CRI has done more than 300 railway bridges also as a part of the studies. And also you can see now the changes in the materials technology. Like you can think about the traditional M15, M20. Dr. N.C. Pal yesterday told about the rail bridge. So it was constructed like using the M20 grade and M15 grade, and still the bridge is very like standing condition, but more than 30 years. So means that the quality design, everything is same. The quality of construction and dedication of the manpower, that is more important. So now we can see that most of the like returning wall and bridges is immediately deteriorating because of the dedication and also construction quality. So coming to the advancement in the material, now you can see that like geopolymer concrete as advanced materials. So a lot of materials are already using in India as a pilot based, and also most of the like recent scientists were joined in CRI. In bridge division, 5 scientists were joined. They're already work in the high end computational and also the like advanced materials. So this expertise to be added to the CRI is like a traditional strength. So not only that, we have already using the digital technologies, structural health monitoring, and innovative construction techniques. Also, we Dr. Naveed Kaur already started with the drone using of the like bridge health monitoring, like unmanned aerial vehicle. So can very much useful to like go anywhere in the bridge deck and any kind of things. Also, we have enhanced our facility, mobile bridge inspection unit. Earlier, we have the 4-lane divided carriage, 4-lane divided bridges. We can able to monitor. Now we have enhanced the MBIU by you for the 6-lane divided bridges. So this is an advantage of additional like a facilities infrastructure facility. So also we have the expansion joint about to end the like NSA people. We have 3 test rigs are there. 2 test rigs are almost like automation condition. Third test rig, we have some kind of technical issues that can be solved in another 1 month. So also like this makes today's lecture particularly relevant. I am confident that the discussion on global advancements in bridge design and construction will provide valuable insights into latest development and the relevant to India. Also, our RC chairman, Mahesh Tandonji, like last 3 years, he have supported to the like his contribution to these institutes. Particularly, we are very lucky that the RC chairman is expertise in the like bridge engineering. So today also we are calling the like MD of that Tandon Consultancy Limited. So with this, like I sincerely thank to Dr. Devjani Raychaudhuri for joining us and for continuing the connection with the legacy of Dr. P Raychaudhuri. So once again, I welcome you all experts. I'm not expert of the bridge engineering. So Professor Dr. S. Gangobaji knows that our area is planning. So, but the alignment which will be designed by the planner or geometry designer, which is the input to the bridge people to fix the alignment on the deck slab. So once the reduced level is finalized by the transportation planner or like geometry designer, the same level will be taken by the bridge engineer and divided and designed for the entire the bridge. So with this, I will not take much time because you people are like to listen about the Dr. Sri Vinay Gupta ji. I also warmly welcome Sri Vinay Gupta and thank him for sharing his expertise, knowledge with the CRRA community. So I think Vinay Gupta is about to join. So once again, like those who are new to the CRRI, like once again, I would like to convey that we are now entered into the Saint Piers of the Platinum Jubilee celebration. So this is a Platinum Jubilee year celebration, is a special year. So already started 16th July 2026 to 16th July 2027. So in this regard, we already started about 16 cities, our work done by CRRI from last 7 decades that has to be discussed and disseminated into various various cities. Instead of doing your work at the same CRI, it is better to disclose or demonstrate your work in the various PWD engineers. For this part of this, why this was started, because like before this Platinum Jubilee celebration year, in the month of May, I visited to the Jaipur. Like their secretary PWD Jaipur requested me to conduct a waste to wealth workshop entire day. So I conducted a workshop. I didn't expect it that morning 9:30 to till the 7 p.m. So all PWD engineers, more than 150, including secretary and a special secretary, they have there like we are all our 20 scientists are presented. So various like waste to wealth materials, flexible payment division people, GTE, except the bridge engineering, all people were presented and rigid like that. That is a concept generated in my mind. So why not? Because most of the PWD engineers, they couldn't able to understand our what we are doing in inside CRRI. And also it's not like that. We have scientists, high-end technical and publication, not only publication. Our work should reach to the common man. So for example, you're designing and like kind of thing. So implementation is the people are assistant engineer. So it should be understand very easily to them. Then only our work should be reached to the common man. So that is the concept. I started the 16 cities concept, and first we did recently an Ampri Bhopal along with the Ampri Bhopal director and CRRI. So there MP PWD engineers 230 PWD engineers were attended, and that program also organized by the Dr. Kanwar Singh is going to retire in this year. So like we have organized the day-long program, and particularly the problems in MPPWD is returning wall failures and also the bridge issues. They requested CRRI to send the team. We have sent immediately Dr. Kanwar Singh and Rajiv Goyal, and they went and they have like explored the problems. So with this, so we have demonstrated what we can able to do for Bhopal PWD. So that was a successful program. First program is completed out of 16. Then second program we are going to do at IIT Jammu, in the presence of the Science and Technology Minister. So particularly this is mainly focused on bridge engineering. So it is important topic. It's not like that most of the civil engineering textbook. We will read about the structural analysis, fundamentals of the strength of materials and more things, but very limited. We are focusing on the bridge engineering. So most of the civil engineers in this hall, they might have studied about the bridges, only types of bridges and different types of the thing. But designing part, we are not much touched because most of the people explore to the structural engineering and building multi-stored building like that. We didn't try it because of the like at that time that not much that much of importance, but very few like experts are there in bridge engineering, bridge design. So definitely this is the one of the area to improve or increase the kind of things. Therefore, we need to explore the designing. That's why I'm humble request to all new scientists, and 5 scientists who joined recently, 2 from the related to the earthquake engineering grade structural dynamics, and 3 from the material side. So all are I requested to that. So focus on designing of the bridges. And also I will explain one story of that one. I said Chandigarh director called me that he requested that one bridge, simple bridge, to be designed. Then I told immediately to the Rajiv Goyal, and so they start with the simple one. So even you start with the pedestrian bridge, also is no problem. But designing is important. So once you entered into the designing area, so automatically you will get an exposure, and then you can increase your capabilities to the high-end bridge engineering kind of things. That's my humble request to all new scientists in the area. Not only bridge has the monitoring and like kind of things. Also, we have to enter into the analysis, structural analysis. You have already PhD completed and PDF you have done. High-end research papers you have, and different fiber kind of things applied. Also, I have one Shoban company from Japan. They approached CRRI. So most of the expansion joint, and they developed there in Japan. So for example, any kind of the expand joint replacement in Delhi, it will take 1 month time. So one side 15 days, one side another side is 15 days. So they have come with a new technology and new materials. And I went with Dr. Navit Kaur, Nitish Kumar Goyal, Rajiv Goyal, and Balla Tarak, and we have attended their presentation. So they would like to join collaboration with CRRI. So their technology, advanced technology that they have implemented in one bridge in Maharashtra. So in a 6 hours time, they will replace the expansion joint, and it will be allowed for the traffic. That is a great advancement in Japan, like high-end technology and high-end material there is. Why not? We have to collaborate with them and exposure and useful, because finally, whatever the experience and expertise which is doing for that will be useful for our country. So we are working for the country. So I request is that focus on designing of the bridges and also exposure to the new technologies and materials. With this, I will thanks once again. I will like to warmly welcome Sri Vinay Gupta ji for his expertise lecture. Thank you. Jai Hind.
Thank you very much, sir, for your inspiring and insightful address. The essence of a memorial lies not only in remembering a person's professional achievements, but also in understanding the values, passion, and commitment that define their journey. We shall now hear from architect Debjani Raychaudhuri. Ma'am, may I invite you to address the gathering?
Good afternoon, everybody. On behalf of my family, my mother, and my sister, I would like to express our heartfelt gratitude to the past and present directors of CRRI, the heads of Bridges Division, and everyone associated with this institute for continuing the Dr. P Raychaudhuri Memorial Lecture Series since 2018. This is now the 9th annual lecture, and it remains a great source of pride and comfort for us that the institution my father called his second home, and where he spent nearly 3 decades of his professional life, continues to honor his memory through this annual event. My father was born in June 1932 into a family that deeply valued education and learning. Too young at that time to pursue medicine, he joined the newly established IIT Kharagpur as part of its first batch. He had the unique distinction of standing first in order of merit for the first ever examination conducted by the first IIT in India. After that, he did not chase any other awards or felicitations. This lecture series to him would be a surprise. He graduated with distinction in civil engineering and later earned his doctorate from the University of Leeds on a Commonwealth scholarship. After joining CRI, he had a distinguished career in bridge engineering, structural rehabilitation, and applied research. His work influenced bridge repair and strengthening practices across the country, and he society, integrity. These values continue to be reflected in institutions such as CRRI and organizations such as Tandon Consultants Private Limited, whose work has contributed significantly to the advancement of the profession and the development of our nation's infrastructure. I believe my father would have been especially pleased that this year's lecture, Global Advancement in Bridge Design and Construction, is being delivered by Chief Guest Sri Vinay Gupta, the Managing Director of Tandon Consultants Private Limited, a company whose principals he knew very well and greatly enjoyed interacting with over the years. This memorial lecture series is therefore not just a tribute to his professional excellence, but also to the spirit of curiosity, warmth, and generosity that he embodied. On behalf of my mother, my sister who's online, and our family, and all those whose lives he touched, I thank CRRI once again for sustaining this national platform of learning in his memory and for us to get an opportunity to hear about his work life and interact with all the people he was close to. Thank you very much. We can now wait for Vinay Gupta when he comes and delivers the lecture. Thank you.
Thank you, ma'am, for sharing your thoughts and reflections with us. I request former scientists, CRRI staffs, guests, and family members of late Dr. P Raychaudhuri to kindly express their views. I request Dr. S. Gangopadhyay, former director CRRI, to kindly share his thoughts.
At the outset, I thank the CRRI management, director CRRI, and the scientists. I think last time I spoke about Dr. Raychaudhuri, some of you who were there, I will speak about him about two aspects. You have to go back to late 70s or early 80s when we joined CRRI. We were struggling with modeling, how to solve complex equations, what would be the methods, whether all models would be solved by heuristic approach, which we learned through optimization. There were a lot of confusion, a lot of enthusiasm amongst the young scientists. Some of the senior members, he suggested to me that why don't you go to Dr. Raychaudhuri and he will be the best person to tell you and clear your doubts. I told him, my goodness, he is head of the division of bridges and structures. Although I scored very good marks in structural engineering in Shibpur when I did my BE, but after that I didn't practice so much in structures, etc. But since the subject was modeling, let me go. I knocked the door. There were another scientist also with me because alone was feeling nervous. पता नहीं क्या हो जाएगा, डांट खाएंगे कि तुमको कुछ आता जाता नहीं है. But what was intriguing was that what I want to emphasize was his simplicity. By the time we came out from his room, I mean, he explained the problem, some of the introductory remarks he spent, what we asked to him. So the point is, the simplicity that he had, and later on, when we used to continue meeting him because of this problem and related problems, his teaching ability. Because I wonder if he would have been a teacher at some whether institutes and IITs or even foreign institutes or universities, he should have been the jewel as a teacher. I tell you frankly, I had a lot of books on simulation and all these things. Those books were good as a reference books, but whatever he inculcated about modeling to us, still I remember those words. So simplicity, as a teacher, I was fortunate. As a young scientist at that time, I could get some lesson from him. And unfortunately, he was not teaching. He was in Bridges and Structures division. At that time, it was BES, Bridge Engineering and Structures. And he was taking refresher course, etc. That is fine. So we didn't have any direct connection because traffic will be sitting here, bridges will be sitting there. And sometimes when there will be some talks on bridges, traffic people will say, oh, bridges ka hai, kya jaake kya karenge. Similarly, it will happen. Bridges ka kuch hai, to bridges wo lagayenge, oh, traffic ka hai, hum jaake kya karenge. But if there was Dr. Raychaudhuri, I would make sure that I must go there. The way he speaks, the lucid way he, interacts, that was something fantastic. The last thing, during my farewell, on the retirement day, 30th of November 2015, this hall, I think, if I remember, when I entered, on that third seat, Dr. Raychaudhuri was sitting. So that gave me, so much excitement. I never knew that he would be coming. I was such a small fellow. And he came, sat there, and he spoke also, sitting there. So those things I remember very well. What Madam Debjani has said, I would not dwell upon his, cooking thing because I had experienced his cooking and tasted the, खाना जो उन्होंने बनाया था. फिर उन खाना खाने के बाद he explained to my wife that how it was done. It is basically chemistry lab. The way you speak and the way you make it as a chemistry lab, the quality of food will be there. So anyway, I wish that this lecture series is a very good approach that CRRI has taken up, and it will continue throughout the years in future also. And I thank everyone, thank the family and everyone in CRRI for enabling me to talk to such a great man, Dr. Raychaudhuri. Is really something I will always cherish. Thank you.
Thank you, sir, for expressing your views. May I invite Dr. N.C. Pal, former engineer and chief, Odisha Works Department, to kindly share his views.
The draftsman address wala na?
Thank you. I'm lucky that again I'm part of this lecture. And I'm lucky also that I'm a product of IIT Kharagpur. I'm also lucky enough that while doing my PhD under aerospace division with late Professor P. Many of you will surprise my PhD is in aerospace dynamics and space shuttle slot dynamics, sponsored by ISRO and ARDB. By default, I am in only. My professor late Professor P. had the same quality what Ma'am Chaudhary said about Professor Raychaudhuri. Ground person used to call us to his firm. He is a complete vegetarian. He will cook chicken for us. We like the students. He will cook chicken for us. In between, he'll discuss. In Kharagpur, possibly in those days, Nehru, Patel, Azad also were there. When the first batch came, we used to stay there for some time. My master's in structural engineering, PhD from aerospace. Over 30 years back, I'm storing. We have a good campus in IIT Kharagpur. Even now, Professor A.P. Gupta was there. Malikan Gupta, the concrete technology group, is very popular. He's now running 87. It's the same quality. Possibly the Institute of Kharagpur, the sweetest state you say, we have love of sweets and other thing. We love engaging and enjoying with people at the same time interacting. The best thing that we all had, the ground to our person scientist, that even a PhD from University of Leeds, he himself is repairing a machine with a green hand. That is the beauty of those days scientists and those days professional, which we may not find in the current level of scientists. In the current new generations, we are being taught, we are getting research PDF on high-end materials. Like Director Abhishek said yesterday, I have shown one bridge photo. It was 53-year-old bridge in Odisha. Many of the states have bridges in those days using sustainable construction material, stone in the substructures mostly. And the superstructure were simple M20 grade of concrete. They are still standing. 53-year-old. Many have the good example. In those days, the high-tech Midas software, APM designs, the DIM digital twins, all are not there. The DPR consultant, authority engineer, supervision consultant, they are not there. But then the great engineers, they understand the philosophy and thought of analysis, the behavioral attitude. And in our day, student days, even in IIT Kharagpur, bridge engineering was a compulsory paper, even in undergraduate. Bridge as an elective compulsory paper. Then in IIT Kharagpur, during my MTech days, I remember, bridge is a compulsory paper. Nowadays, with the change in AI and IT technology, even in undergraduate courses, the bridge is only being taught as a terminology subjects. That's why in our country, we are not getting bridge engineers who understand the basic behavior to the advanced design. There are very few people like my Tandon, Bina Gupta, Mathurji here. Many of us who are working in IRC Bridge Committee and in the UHPC code, Ultra High Performance Concrete code that has been approved with the recent council has bridge up to M200 grade, and some of the M200 grade bridges have already built in Pune and Maharashtra. It's not the high technology bridges, but we don't know what will be their long-term performance. We are not yet sure. So from M20, we have gone up to M200 grade of concrete. Long span, 100 meter span, single span. So the foundation will get reduced. That's why that is the present topic has been very nicely chosen as global advancements in design and construction, all advanced design, advanced construction. Abhinav Gupta is involved from the segmental bridge long back to all the cable stayed bridge and new technology bridges. So everybody, I think, will enjoy. And I thank CRRI and I also request CRRI that try to continue this type of memorial lecture, particularly with such a strong talent like Raychaudhuri, whose entire contribution to CRRI is on bridges and the equipment that was developed, demonstrated in those days are still in use. The fundamental principle is used, though we are coming to drone-based sensor, vagara, and we are calibrating them, getting some data, but those fundamental equipment from simple UTM to simple expansion set, simple bearing testing machine, those test bed are still in use throughout the globe, not only in India. So I thank you this good one and thank the entire family of Raychaudhuri. Thank ex-director Namapadyaji, Ram Kumarji. There are veterans sitting here. Geruarji, they are conversing. I heard that he's going to return. There are very hardcore researchers in CRRI. I used to tell my research that get the involvement of CRRI in all rituals. So you get knowledge, experience, background, and motivation to work instead of thinking you are as a typical PW engineer. With this, I thank CRRI again to give me the opportunity to talk. Thank you.
Thank you, sir, for expressing your views. May I invite Dr. MVP Rao, former head BS, to kindly share his views. Ladies and gentlemen, our chief guest, Engineer Vinay Gupta, has also arrived. May I request him to kindly come to the dais. I request Dr. C.H. Ravishekhar, Director, CRRI, to kindly welcome our chief guest, Engineer Vinay Gupta, by presenting a plant. I request Dr. C.H. Ravishekhar, Director, CRRI, to kindly welcome our chief guest, Engineer Vinay Gupta, by presenting a plant. Thank you, sir. May I invite Dr. M.V.B. Rao, former head Bridge Engineering and Structures Division, to kindly share his views.
It's already late. However, since I was requested to talk something, I would like to speak only for a few minutes, so that we are not disappointed. First and foremost thing is, as a human being and as an engineer. As a human being, let us say, I was 12 years younger than him, just joined the scientist B in 1969. At that time, Dr. Mrs. Raychaudhuri was doing PhD in the IARI in Pusa. So he used to go in the evening to pick her up and then bring her back to Lajpat Nagar, where I was also residing very close to the residence. And he would take me there every day because in the first 2 months I was staying in Karolbag. Later on, came to Lajpat Nagar. And that is, the simplicity he had. I was very much a junior person, very much younger than him. That is number one. Coming to the scientific side, he was known as a very good engineer and a good scientist also. Once I posed this question, how come you do? You seem to know everything. Please understand these clear words. He said, जो मेरे को मालूम है, वो ठीक मालूम है. Not that bluff or whatever it is, that's what he told. And he used most of the physics principles in analyzing many structures, as a matter of fact. And there is one feather in cap about which I would like to speak a little. That is the decentering of roof of indoor stadium in IP Estate, that is now known as IG Stadium. It is a very heavy structure of that time. In fact, the knowledge of space structures, as you call them at that time, was available at the University of Surrey, Guildford, where I also studied. And they were designed more like a lotus. And they are all heavy steel structure, as a matter of fact. And the erection itself is a very complicated one. I don't want to go into that. Most important thing is the central ring, as you call it, to which the trusses are attached to 8 pylons all around, but to be lowered after the erection is completed. And as expected, ball went around. CRRI took up that assignment. And it is a very risky job to me also. I was going up on something like a cage, install the equipment there in the top level with my colleagues. And the expert, Professor ZS, my Jazz Makurski from the University of Surrey, Guildford, came here. And then he told what are the improvements that have been made. Believe me, the decentering operation started at 9 p.m. on the 29th of January, 1982. And it continued till morning. And all of us remained there on the other side. And the centering could not be released. That is to be released, so that the final arrangement is to be made. And he took the greatest risk in climbing up. And with his own ingenious as a college, he told the people how to jack up and jack down. And finally, stress was brought down. It was a Diwali type incident only, around 10 a.m. This is what I want to say. He was not only a genius, as a matter of fact. They were too good in engineering, particularly solving that particular problem. Nobody could solve it. This structure was erected by Triveni Structures Limited, Allahabad. Sorry, that in near Allahabad. That's it. So, he is my guru in every sense of the word. I bow down to him in all humility. And when the proposal to start this lecture series were made by her, Dr. Mrs. Raychaudhuri, he then director, Professor Satish Chandra. He was hesitant. He said, "Why? How come it is done?" I just told him just one thing. Sir, I mean, bridge division is the only thing, structure division in CRR. And he's the founder of it. And it gives a good impetus for all those scientists in CRR as to what exactly is bridges. Otherwise, nobody was knowing much about bridges, although it started as a subject of structural engineering. So that is how the whole thing started. And you took the initiative and then we're now continuing. So this is the 9th one in the series. And Dr. Vinay Gupta, I call him a doctor only because he's a brilliant engineer, no doubt about it. I have known him for more than 25-30 years. So please listen to him. Thank you very much.
Thank you so much, sir, for sharing your thoughts. Ladies and gentlemen, we now arrive at the main part of today's program. Before inviting our chief guest to deliver the memorial lecture, let me take a few moments to introduce the distinguished personality who will be sharing his expertise with us today. Engineer Vinay Gupta completed his civil engineering from BITS Pilani in 1983 and joined Tandon Consultants Private Limited in 1987. Over the course of his distinguished career, he has been associated with planning and design of a wide range of complex structures, including bridges, flyovers, vehicular underpasses, long span structures, tall buildings, steel structures, and chimneys. His professional contribution extends beyond individual projects. He has been an active member of various standards committees, including BIS and IRC, contributing to important areas such as earthquake engineering, special structures, load and stresses, concrete bridges, bearing and expansion joints. He has contributed to preparation of important IRC publications, including IRC SP 65, Design and Construction of Segmental Bridges, and IRC SP 71, Design and Construction of Precast Pre-tensioned Girders for Bridges. Engineer Vinay Gupta has been honored with awards for best paper titled Seismic Design and Construction of Radisson Hotel New Delhi and Launching System for Segmental Bridges, both by IBC, Priestess Concrete Design Award 2023 by Institution of Engineers India, coveted SP Joshi Memorial Award 2019, Eminent Engineer Award by IEI, etc. With around 100 technical papers to his credit, Engineer Gupta has also actively involved in teaching and sharing his professional knowledge, serving as a guest faculty at institutions including NIU, THE, CRRI, CIDC, ISTA, and DPC. He is the immediate past president of Indian Concrete Institute and is currently president of Indian Institution of Bridge Engineers. So, ladies and gentlemen, it is my great honor to invite our chief guest, Engineer Vinay Gupta, to deliver the 9th Dr. P Raychaudhuri Memorial Lecture on Global Advancement in Bridge Design and Construction. I request the dignitaries to kindly take your seats. Online participants are requested to kindly type their questions in the chat box.
So I can run from here.
Okay, so good afternoon, everybody, and I'll begin with a big sorry, extremely sorry rather, for this 1 hour delay that I have made you all wait, and extremely thankful to you as well because you waited for 1 hour for me. Just wanted to tell you that I had very fond memories with Dr. P Raychaudhuri. We have worked together with him on many projects, and he was a fantastic combination of an excellent knowledge bank, especially in the field of his testing and repairs and retrofitting, and the softness, the kindness, the smile on his face all the time. And I used to wonder how I mean, is it that he doesn't know things and so smiley, or is it that he's just a magician, that he has both a combination of the two? Anyway, so these things I'm sure have already been talked about. Just didn't want to spend too much time on this. But yes, it's a good gesture of CSIR, CRRI, and Mr. Roy Chaudhary here to have organized these lectures every year. And we have association with his daughter as well. So we have a good association with the entire family, I must say. All right, so coming to some of the slides that I will pick up and maybe skip few because I have to try and cut it short by about 15-20 minutes at least. Then I have a meeting to attend. So it will be in the car now. So very first that we see, and you're an architect, man, is the architecture, the aesthetics. So when we say aesthetics in a bridge, we normally think of a curved bridge, a curved structure of any kind. And here is a structure where you see the first one, which is here, which is having a curvature, like it's an arch. Arch usually or typically or principally carries in membrane forces, in plane forces. So every vertical load is converted into two components. One will be along, other will be perpendicular. And therefore, perpendicular balances out to quite an extent. What is this? Oh, somebody wants to admit. All right. Whereas the horizontal force accumulated together of reaches the starting point on the two ends. As a result, we need large foundations at the two ends. And these foundations have to be able to take the horizontal force. And therefore, typically these foundations are like this. Fine. And of course, in this particular case, you have deck on top, and that is it. Arch takes the more or less the entire sort of loads. In the second case that you see, this horizontal force I was talking about is not required to be carried by the foundations for the reason that you have this deck which is here. It's a bottom hung deck suspended through some of these suspenders. And this deck would do the job of acting into tension by connecting to this and to the other side for the axial outward forces. And therefore, you don't need massive foundations in this particular case. A slightly smarter solution is what you see in the third case, where you have an arch, which will be exerting as usual the horizontal forces. But then you have a short arch connected to this. And these arches are connected to the deck, which is going to carry the traffic, and they're all suspended through these suspenders. And as a result, this member, the deck, still is a tension carrying member, but it relieves the foundations at this place and this place, which I think is well understood by all of us. And you are into a research institute, I'm sure. It's well understood, just that I'm trying to introduce. I'm skipping some of these. Yeah, we come to this project, which is 120 meters span arch bridge. And this is over river Parvati, which is quite a turbulent river. You cannot place staging to construct this arch. So there has to be some technique wherein you construct all above without touching the water, without requiring any support, any scaffolding from the water. So in this particular case, if you see here, for this 120 meter span, we have massive foundations, the well foundations, which support the arch as well as the horizontal force, because we don't have the facility of doing something else for it, and there are reasons for it. So in this particular case, the construction river is here, which is quite turbulent. The construction is done using stay cantilevering arch segments, all in situ. Each segment that we construct every time will be approximately 7 meters. And there will be underslung formwork here, which will be a traveling formwork as we call it, traveler, which supports the concrete during the concreting period and which has all reinforcement. And once the concrete hardens, that support can be moved forward for the next construction on this side or on that side. But thing is that if we just do this, then this fellow will become too thick for a span of 120 meters. At least cantilevering of 60 meters and 60 meters on the other side. So to avoid that temporary force that we have, we don't want to spend on concrete and reinforcement for the temporary condition of construction. We rather provide these 45-meter tall temporary pylons. And these pylons are connected to some heavy backstay. And in the forward side, they have several connections to every stage of the concreting. And when it reaches, it's about to hug each other. Then we have this traveler, which one of them is removed, other one is bridged over the two sides, concreted, and the arch is complete. This arch, since it is connected to heavy, well foundations, it is self-sustaining. It can take its own force, its own loads. It can also take the loads of live load and deck and all that. After that, we use those suspenders here, which are permanent suspenders, to suspend the shutter, cast the concrete of the deck, and thereafter we remove the shutters. Suspenders remain. Now, when it comes to an arch bridge, or rather aesthetics, in aesthetics, it's very important how you proportion the structural components. Now, if you look at this bridge, America on the right side, Canada on this side, left side, and we have this bridge where you pass through and you have an immigration office to cross. And one day, in fact, we crossed it 2 times in a day to reach from Canada to US, back to Canada and back to here. So this is Ori River that falls into Ontario River in Toronto side. Now, imagine if this bridge was made like that, then the tourists will forget they came to see the bridge or they came to see the greenery behind and the waterfall in front. So they proportion, at the same time, they made the bridge flat, horizontal. Then also it won't be appreciated in these surroundings and the tourists coming in there. It will look like any flyover or something in the city. So they've gone with a very good combination, wherein you just see the greenery behind over the bridge. And it's about 250 odd meters. Okay, now we come to something which is seismic friendly. Seismic friendly, when we say we try and avoid bearings, we try and make integral bridges, wherein between the pier and the superstructure, there is no pier cap, there is no bearing. It is just simply connected like a building frame. So in this case, if you see in Kuala Lumpur or any airport, Delhi airport or wherever we go, there is a sharp curvature for your alighting. You reach the airport terminal, take a sharp curvature, and then you're on it and you alight. So that sharp curvature becomes often unstable in rotation, in the overturning. But once you make it integral, that problem is automatically taken care of.
Yeah.
So this is the construction picture of the same bridge, but I show a slightly better example. Here, there is a flyover, part of the metro, DMRC. This flyover, due to several constraints below, piers are almost parallel to the superstructure. It is a skew of 70 degrees, not 10, not 20, not 30, not 45, it is 70. Now, in those conditions, there's no way you can provide bearings because bearings will lift up, the structure will be unstable for sure, and there'll be tensions in the bearing, they will lift up anyway, and there'll be complete redistribution or redistribution of forces. Because once the support lifts up, the forces start redistributing further. So to do that, to avoid that, rather, we provided these 5 sets of piers, integral bridge completely. And of course, you see various complex analysis that you have to carry out. Each pier, which is at a 70 degree skew, is like this. Means as opposed to being 90 degree, it is 20 degrees to the structure. And then, of course, you have abutments. In this particular case, we have idealized the abutments as well into the structure with all their piles and everything, so that they share into the stiffness, the earthquake forces, and at the same time, the flexibility of piles gives some relief of the breathing forces. We can always discuss it in detail. Now, another project which is what do you call it? Aesthetics masterpiece at Ames or the Safdarjung, wherein the flyover has been lifted slightly and the road below has been lowered slightly so that you don't have a height of 9-10 meters. You just have about 4 meters or so above the ground and rest of it below the ground. Of course, we had an architect for this, one Mathur Kapre and Associates, who did the architectural designs for it, and we did the structural design. But idea basically is that if you see this picture, people normally, especially architects, they say that metro is an eyesore. Flyover is an eyesore. Make underground. But then owners, clients, the government say, no, no, it's too expensive. Don't do that. So all this combination here, we did some in between. Yeah, this is just one more picture. Yeah. Now an architect designing a cable stayed bridge. That is Santiago Calatrava is a world famous architect. Rather, he's a structural engineer turned architect, which I'm sure architects will all know about him. They know about it. They do know about him. Now, this fellow said that in a cable stayed bridge, you make one pylon and you have half structure on left, half structure on the right, and you balance it out. Very good structurally, perhaps, but I don't like it. I want something different. So that different he chose was to have structure on one side, superstructure, and pylon on the other. The problem in the process was that how do you balance this structure, because there is no structure on the other side, so you cannot have possibly a vertical pylon. So what was done for this span of about 200 meters superstructure, to make the superstructure light, that is structure steel, and to make the pylon heavy, that's in concrete, with huge metal plates inclined at about 30 odd degrees, I think 32 degrees to the vertical, so that a two can balance only imbalance part of it, like live load or anything else, or seismic force will be taken through bending moment in the pylon and the supports. But rest of it is balanced out in a different manner. Here, there's a challenge in the construction. There's always a challenge in the design, and designs have to dovetail the construction. That's a part and parcel of life. We have to do this. But then you see something which is different. And you know that Namaste Bridge in Delhi is kind of an example, sort of an example of similar thing, or probably the next thing if you see here. Here is a span of 284 meters. This new other architect, Ben van Berkel, I don't know if Madam has heard about this architect, Ben van Berkel from Dutch architect. He said, I'll do something different. I'll not make an inclined pylon. I don't like it. It looks like it's falling back. So I made a vertical pylon. But then structure being on one side, how to make the pylon stable? So he has provided these heavy metal backstays anchored to the rock on this side for the balancing part. And the structure is entirely on one side with a 284 meter span. And I'm told even the bearing course is in polyurethane to reduce the weight and not this black, bitumen and other things or concrete or anything like that. Good. So another interesting architectural masterpiece, 105 meter span, a pedestrian bridge, but also serving the function, and that's what I wanted to discuss here, is that you have a river inside the city, and then they have to make this gate shed Millennium Bridge in 2000, more or less. And what they did is to make the bridge curved. That means you walk little more to reach the other side. It's a pedestrian bridge. But the advantage, let us see. It is supported by this arch with the cables. And it is on heavy pivots on left side and right side, which can hydraulically rotate. So that when any of the boats come in, which require a larger clearance, you have on this side you put a signal red, and you say pedestrians, please don't move, and bridge is rotated, lifted up, and then the boats pass through. I don't admit, not be able to move forward. Okay, yeah. Yeah. And this whole thing, weighing about 800 tons, were manufactured somewhere else, brought through a high capacity floating barge rig up to 3,200 ton capacity, brought to the location, placed in location. Okay. And of course, the other benefit was aesthetic. That is, it looks like a necklace of a princess in water at night. All right. Another interesting masterpiece of not only aesthetics, but also the construction facility. Construction, indeed. What the people chose, it's a architect, sorry, it's a structural engineer from Japan. And for this 57-kilometer long Bangpli-Bangpakong Expressway, BBB Expressway as we call it, is to make a single box structure with some struts and all, width of 27 meters, and supported on the H-shaped piers. Now, as I said, the advantage during construction for this H-shaped pier, apart from whatever aesthetics you see later on in service, was that the launching girder, which is underslung type, could be supported below. So this launching girder would pick up the segments, bring them up, rotate 180 degrees, place it on the launching girder, and of course, take it to the farther end. These are the segments which are 27 meters wide with some struts, no multi-cell box and all that, and transversely pre-stressed, of course, weighing about 150 tons. This I think I'll have to skip. Okay, let's come to one 10-kilometer long elevated expressway in Bangalore. This is about 15 years old project. Here, it's a beauty project, and we wanted to do justice to the traffic, being a beauty project wherein people pay some money for it. So we provided expansion joints at every 262 meters, which means it is a 8-span continuous structure module. The many such, the total length is 10 meters, in such a way that they are 29, 34, 34, 6 times and 29 meters, so that you get a tuck sound only after 1/4 kilometer. Now, the construction method is what I wanted to actually bring out, because design goes by that construction, is that, you have this pier segment and the regular field segments, precast segments, epoxy jointed, internally pre-stressed. The launching girder, as can be seen from top. What we just see here, there's a bracket connected to the pier, and this bracket has a use. The launching girder in certain stages is first placed on the steel bracket, which of course later is taken out, no doubt. Same way, now, after this, the load of the launching girder is transferred to the pier segment, like this and like that. But initially, when the pier segment is not there, you first transfer the load of the launching girder to the bracket that you see in front, the blue one. And thereafter, with the same launching girder, you pick up the pier segment, place it here, and transfer the load of the launching girder onto the pier segment. And then, of course, this becomes redundant. You can remove it, take it to the next pier. So here is that one more picture of that. And in order to cover up the height, there is a kind of a frame which it just covers the height of the segment, which is 2.5 meters, I think, in this case. So this is one more picture. Let's go forward. Now this pier segment, which has to carry the launching girder, whose its own weight itself, self-weight itself is 400 tons. And then it has to lift the segments and so many things, and the height and the wind and everything. It is connected to pier cap with the help of these vertical pre-stressing, which is a temporary connection. And when you connect it like this, you also have these bearings here. So it's a sandwich of pre-stress and the bearing, sorry, not bearing, hydraulic screw locked jacks. below. So this becomes completely a locked segment, the pier segment,
Let us
over
try.
which you can place whatever load you wanted to place, which is the launching girder. Now, once that happens, launching girder is moved to the location. Now you start erecting the segments on the ground. They're ground fed. And these segments, like this, they are picked up and assembled over a length, which is suspended from the launching girder. They are not underslung. And then you create spaces for application of the epoxy bonding agent. And after that, you can lift it up. In the process, you have to adjust the segments transversely, longitudinally, vertical, grade, profile, inclination, and everything. And all those things are very well done using this wireless remote controlled gantry.
I'm sure.
I mean, the remote control that operates a traveler,
Take
the
time.
launching girder. Now, casting.
Time
Casting of
that-
these segments, this is external shutter, which will be
Yeah.
simple to grasp.
Good.
And we have some liner used here for shape of the segment, which is ribs kind of a pattern. Now, there's not enough time to really do many things
What's
together.
that?
So you have this
What's
internal
that?
shutter, which is a ready-made shutter, which is collapsible shutter you can collapse. It comes onto this attachment, which has a counterweight, is cantilevered out into the segment. So we have outer shutter, we have inner shutter, and we pour concrete after placing the reinforcements and your ducts.
I'm certain.
Once that is done, now
I'm
it's a
certain.
short bench method wherein you just need two spaces or two beds space. You don't need a long space.
All the structures.
So this system that you see, it takes out the previously cast segment and next segment is cast against the just previously cast segment. So that process goes on of lifting, of removing the segment from the trolley below. This is only casting. With this speed, with this process, they got a speed of 1.5 days per segment per such bed. So that's the statistics. Now, when you're casting the segments or segment against a segment by match casting technique, then you need adjustments for the transverse profile and longitudinal profile both. So the flyover is not a straight line flyover of 10 kilometers. So to do that, there are jacks for transverse adjustments and for longitudinal adjustments.
Accepted. Without
Reinforcement is also pre-done, brought in, placed into the
Any
shutter. So that time is also saved. And that is the way that entire process that you see is 1.5 days per segment per bed, all put together.
ASME.
Now, how we did the construction is interesting. How we conceived the design and therefore the construction. We said we'll not do the entire span like many people do, that's simply supported and then continue later on. We said we'll do only 1.25 span. So that this negative bending moment will reduce the positive bending moment. So there's a cantilever attached. Then we do 3/4 and 1/4. Then we do another 3/4 and 1/4. Likewise, we went on doing till the half of the structure. In analysis, we analyzed only half of it.
ASME is a
Interestingly, if anybody is a designer here, he will appreciate, he or she,
first
is that when you do this, every now and the forces vary. Because there are shrinkage losses, creep losses, and few other relaxation and other losses are time dependent. And as you see, 99 days, 300 days, and 10,000 days, which is like infinity, the stresses in the concrete have gone on varying with time. Now, my structure must be safe on day one when I give it to the people to start running the traffic, and it should also be safe on the infinity time. So prestressing has to be so adjusted. Secondly, when the live load is made to move over the structure in various conditions at every segment or every section, there are positive bending moments and negative bending moments, both. So structure must be safe for both these bending moments when you do influence line diagrams or moving load analysis. Okay, so I think I'll take another 15 more minutes. This is a cantilever construction. We know, I'm sure we all of us know very well. But why we do cantilever construction? It can be two types: cantilever construction or balanced cantilever construction. So what I'm showing you here is a balanced cantilever construction first, wherein you construct from this side there and also this side there on both the sides, and the two sides principally remain balanced. So after having constructed these piers, which in this case, some of them are as tall as Qutub Minar, 70 meters, the hollow piers, we cast the first segment, which is approximately 9 meters high in this particular case. It's a railway structure where there's a ballast over it. So the railway load, live load, there's ballast load and everything put together. The depth of this is about 9.4 meters to be precise. We first cast first segment, which is approximately, you don't see it to the scale, but that's approximately 10 meters here. Now, mind you, the pier cap here that you see over the hollow pier is 5.4 meters or 5.5 meters. So what we do is, we first of all, to cast the pier cap itself, we leave holes in the pier. But that height, there's no possibility of putting a ground supported staging. So through the holes, we pass through eye girders or plate girders or whatever to cast the pier cap. Over the pier cap, we once again put those kinds of girders to cast the very first segment. You cast it and you stress it. An analysis has to be carried out, design has to be carried out for this stage of construction. Okay, so once you have done this long segment, the first segment, why it is 9 or 10 meters is we want to make a simple arrangement of supporting this traveler or traveling formwork, that complete assembly is here and complete assembly is there, and they will move both left side and right side, both ways. Now we have already pre-stressed the first segment. Now we have this traveler which hangs the shutter, the reinforcement, the pre-stressing ducts, and you pour concrete there. And once you've done that, you pre-stress from here to there, pre-stress from here, this left to right end. So this is a level 2 pre-stressing. Again, your structure must be safe, so analyze and design the safety of stresses. Then you go to the next segment and next segment. Of course, just to tell you, which I probably not mentioned, is that since there is a hanging load, there will be a compression under the truss here, and there will be a tension under the truss there. And for that, we connect the truss here as well as here. One takes the compression, other takes the tension up it. And of course, gradually they start meeting. Yeah. Now we go to pre-tension. I think that should be my last item of the day so that we don't delay your lunch too much. Pre-tension is something different from post-tension. In post-tension, which has been very common over the ages, over the years, is you pour concrete, maybe I'll here. In this, you pour concrete and leave these ducts, the tubes of any kind, metallic or high density polyethylene, in such a way that wherever you expect tension to come, like if this is a support, you can expect tension here, you provide at the top. This is a midspan, you expect tensions at the bottom, you provide like this. You go like that and go like that. You provide these ducts. Once the concrete is hardened, then you thread the cable and then you stress from this side and that side. Typically, that is post-tensioning, what we do. Pre-stressing has two branches, post-tensioning, pre-tensioning. But when we go to pre-tensioning, that is the example here. Yeah. When we go for pre-tensioning, the first we do the stressing, and thereafter we put the reinforcement and we pour concrete, which is the second case that you see the low one. Now in this case, you need heavy abutments against which you can tension the strands, and thereafter you pour concrete and then release the force. Okay, in post-tensioning, I hope everybody understands this. I need not explain what is a wire, what is a strand, what is a bearing plate, what is anchorage cone, and what is wedge, and what is circlip and how it is done. So I'm just taking an advantage of knowing, presuming that it doesn't require explanation. Okay, in pretensioning, what is done is like this. We have a casting bed, like in this case, 4 of 25 meters, but girders can be cast together, 4, and likewise totally 14 girders in this case. Here we have a stressing area, here we have a dead end area. In the stressing area, we have jacks. They can pull the strands before you pour the concrete, some pictures like that. Yeah, we see the shutter mode, which is just moving in and out, the one single piece shutter over rollers, the rollers below. And this is the thing we call it trolley in the crude language. But it's a thing which engages the strands and you use jacks to pull this backward. Yeah, like this. You have jacks to pull this trolley backward in such a way that the strands get pulled. In a particular case like this, which is approximately 100 meters length, 3 of 30 and 4 of 25, the extension of the strands is approximately 600 millimeters. So we have planned the jacks in such a way that a single stroke of the jack can take the 600 millimeters of the extension. This is the dead end on the other side. Just a little bit of a comparison. Let me not go through all these long text. Comparison is that pre-tension girders require initial setup. That may cost anywhere around 3 to 5 crores of rupees. But they are much cheaper in running because you don't require ducts, you don't require anchorages, you don't require grouting. And at the same time, the pre-tensioning strands, they work like a stressed reinforcement, not like a cable. As a result, the thicknesses of the webs can be thinner as like in RCC, because you don't have to subtract the duct area. Whereas in the case of post-tensioning, you have to subtract that area, thing becomes thicker, and therefore the weight. So weight, transportability, erection is ease, and at the same time, the earthquake force. That's how the weight, that's how the earthquake force. So all these advantages you indirectly get more like free of cost if you do this pre-tension. But why everywhere we don't have pre-tension is because it requires an initial setup costing 3 to 5 crores. So whenever girders are more than about 200, it turns out cheaper to do and faster, of course, because you construct 14 girders at a time. We can even be doing more and pre-tension. Yeah. So it substantiates that cost of 3-4 crore by making it faster, lesser material, and many other advantages that I said, no grouting and this and that. And therefore, beyond 200 girders, pre-tensioning becomes much better. Now, pre-tensioning has one limitation that your strands can only be straight, whereas the bending moments cannot be straight. They will always be following a parabolic profile. So certain end parts of these strands are debonded so that they don't participate, as if they are not there in that area. That part of the strands are wasted. Because of this, there is a limitation approximately, on practical side limitation, is about 30 meters people can design. But recently, we have slightly gone beyond for a project in Mumbai that we have gone with 40-meter long pre-tension girders. All right, so last 5 minutes. A cable stayed bridge, that's a Normandy cable stayed bridge in France. It has a span of 856 meters. They decided to have 1/4 span in concrete on either side and remaining middle half in steel to reduce the weights there. And these are the anchor spans and also the viaducts otherwise. Pylons are here, which may be approximately 25% of 856 meters. Now, typically the construction of a cable stayed bridge is a balanced cantilever construction or a cantilever construction, let's call it. In which case, every time you do one segment of around 8 to 10 meters and you put a cable which is connected, then you do one more segment, put a cable, suspend the cable from the pylon. That's a permanent cable, mind you. And you go on and on like that from both the sides. That is a normal way. It had world record for some time. Now, this At that time, the world record in 1999 was demolished by this Tatara bridge in Japan with a span of 890 meters. Now it is much bigger. Now I think it's 1200 or 1300 meters. Stone Cutter Bridge and few other bridges. But basically, the problem they had and how they came over this problem, how they surmounted the problem is that to make 890 meters, they first of all made it very light, that's steel. But again, to have a balance in the pylon, they made this thing in concrete, left side and right side, because they could not have longer than 270 meters due to hills right next and due to hills right next. So they made the end spans in concrete, middle span in this steel, and that's how they could more or less balance the vertical load forces into the pylons. Suspension bridge. At any given time, suspension bridge can give you a larger span with the same technology that you use compared to cable stayed bridge. So we have cable supported bridges with three categories, subcategories in that. One is extra dose bridge, other is cable stayed bridge, and third is suspension bridge. In suspension bridge, we have a pylon which is much shorter than what you have in cable stayed bridge. It's about half of that. And you have the main suspension cable, which suspends several auxiliary cables, which you see, the vertical cables. The only punishment to this comes at this end of the main cable, where there's a huge amount of horizontal force. So this is like a rope, catenary. I'll skip this. Yeah, Akashi Kaiko. So world record of this Akashi Kaiko was held for almost like 20 over years, with a span of almost 2 kilometers unsupported. So total length of 4 kilometers, 960, 1990, and 960, almost 4 kilometers. Suspension bridge, two-level rail-cum road bridge it is, width of 35 meters, all in steel, as you notice here. And so it was held for 22 years, I think. So that's how it is. 39. This is yeah. So this is Kobe Strait in Japan, where we have this 4 kilometer long bridge, and you see these. Now, interesting thing is that this pylon here is in steel, which is 297 meters. The cables are 1.122 meter diameter, the main suspension cables, and steel deck, of course. Now, these cables, each one, the parallel ones, each one weighed 40,000 tons. Can anybody imagine how they carried the cable from one side to the other? They could not be hanging from a helicopter. So what they did was, it's a straight, narrow area, but not shallow. A straight creek and a straight, that's a difference. So they used a combined power of high capacity helicopters and barges to pull the cable from one side to the other to get this 10 ton per meter weight of the cable. There are a few other stories, there are histories attached in it, which I am skipping. This is just a pylon under construction, which is in steel, mind you. Caisson, there was a cluster of wells that is made as foundations of this pylon. It's not one well, two wells, it's a number of them joined together with a well cap or other multiple well cap. This is, of course, one caisson that is being taken to that location. Anchorage foundation will be normally where this is anchorage foundation at the two ends where the main ropes get connected. Yeah, this is a main rope, connection place where you have a heavy foundation to take the entire, good amount of, very large amount of horizontal force. Okay, so this has been not demolished. This world record of Akashi Kaiko Bridge, they enjoyed for 32 years and demolished some 3-4 years ago, I think 3 years ago, by Turkey, which is Kanakkale Bridge, 1915. 1915 because they completed the 100 years of independence or establishment of the country. So they said we have to make something, but they could not really make the bridge functional in 1915. It became, I think, 1922, if I'm not wrong. Kanakali Bridge. It has a span of 2,023 meters. So it's little more than 1990 and 770 and 770 and the approach spans. So likewise, they have been able to do that. So people make this kind of world record bridges, not only for just solving their traffic, also for creating a world record that people come and see. Visitors will go, tourists will go, and they will want to see that, especially a person like me would like to go and see. So anyway, that's how we are. So I hope CRRI has a big contribution in all these kinds of special projects. Thank you so much.
I request the dignitaries to kindly come to the dais. Thank you very much, sir, for that exceptionally informative and insightful lecture. Your presentation has given us valuable perspectives on evolving landscape of bridge design and construction. I request. Do we have any question from audience? Okay. Sir wants to ask.
Thank you, sir. Thank you, sir. It is always a pleasure to listen to you. And this special officer, it's a ninth Dr. P Raychaudhuri Memorial Lecture. It's you can say now I can say that hereditary sort of thing for CRI. So I'm also from CRI, so it's my privilege to speak a few words. First of all, compliments to you and for such beautiful and icon project. And particularly the case history of that Turkey bridge, that may be a news for many of us. So thank you very much. You ended up saying that CRI may have got an association with you can say similar type of projects. Yes, sir, particularly this aspect. And before that, it was Dr. CRI's address in which he was specifically mentioning about you can say the analysis and design aspects. But being a R&D institution, I think the detailing aspects as well as the infrastructure projects pace, I don't think that CRI directly can get involved with that. Yes, of course, the review of the analysis and design, the stronger you can say the aspect of CRI is the experimental evaluation. Even for this type of bridges, means that suspension bridges, the health monitoring aspects, the one UHPC talked about by Dr. Paul, is a special type of, you can say, experimental evaluation techniques. And one, since you are also in our B6 committee, and will be hearing from him that CRI is in the process of developing expansion and testing facility. But that is still in the trial stage. So my appeal at this forum to Dr. CRI would be kindly, because you being in a B6 committee, you can say representing the nation, we know that this is badly needed for the industry to improve the quality aspect. So this is the real flavor, where real flavor of activities where CRI can involved. And in true sense, what is your opinion in prestigious events like this? By giving, you can say, contribution in this aspects, definitely CRI can contribute to the nation in a hands-on way. Thank you very much.
Thank you, sir. Do we have any questions? Okay. As a mark of our respect and gratitude for his valuable presence, for sharing his immense professional experience, and for delivering an enlightening memorial lecture, we would like to facilitate our distinguished chief guest, Engineer Vinay Gupta. May I request Director CSIL CRRI, Dr. C.H. Ravi Shekhar, to kindly facilitate our chief guest by presenting a memento and shawl. May we have a round of applause, please?
To have a section on aesthetic in bridge design. And in fact, you have highlighted aspects for that.
Favorite topic about aesthetics.
Yes, so being able to highlight that says like topic is different, but content is different.
As we approach the conclusion of this memorial program, it is time to express our gratitude to everyone who contributed to its success. I now invite Dr. Navit Kaur, Scientist E, Bridge Engineering and Structures Division, to deliver the vote of thanks.
Distinguished guests, respected dignitaries, and esteemed colleagues. As we conclude this significant gathering, I would like to take a moment to express heartfelt appreciation to all those who have contributed to the success of today's proceedings. So first of all, I would like to thank our chief guest, Shri Vinay Gupta ji. We are deeply grateful for your enlightening address on global advancement in bridge design and construction. Your insights and expertise have provided us with valuable knowledge and will undoubtedly inspire further research and innovation in the field. Our heartfelt appreciation goes to Dr. Malini Raychaudhuri and Dr. Minati Raychaudhuri for their presence and participation. Your contributions have added a personal and pioneering touch to today's proceedings. We are also grateful to architect Debjani Raychaudhuri for joining us and honoring the memory of your esteemed family member. A special thanks to our respected director, sir, for your gracious welcome and thoughtful felicitation of our chief guest. Your leadership and commitment to excellence continues to inspire us all. I would also like to thank all the invited guests, our past director, CRI, past head of the bridge division, and the retired officers who have graced us with their presence today. Your participation has added great value to our event. We are truly honored by your presence and your support. We extend our sincere thanks to Dr. Rajiv Goyal, Head BES Division, and the whole BES Division, especially Sri Durga Prasad Golaji, Dr. Shubham Saurabh, Sri Yogendra Singh, and Sri Narayan Rao for extending their support in organizing this event. I would also like to acknowledge the efforts of ESD Division, CCN Division, ILT, Rajbhasha, Horticulture, Administration, and the canteen staff involved in planning and execution of this event. Your hard work and dedication have ensured the smooth running of today's program. Thank you once again for your presence and making this event memorable. Have a wonderful day ahead. Jai Hind.
Thank you, ma'am. May I request all the guests to kindly come to the stage for group photo? Niche, Anand. Okay, we will be coming downstairs.
कुछ लोग पीछे जाइए